Okay, welcome everyone. It is just past 6 o'clock, so we're going to go ahead and get started. I am without my usual co-host Blake Blaze tonight. Blake has a prior engagement, so I'm going to be running this one solo. And this one has a special focus on science fair. I know that this is science fair season. A lot of students are preparing final projects. A lot of teachers are helping to coach and mentor those students on those final projects, and want to talk about using DataClassroom to do some of that work, and also go over some principles for working with data that really pertain to survey data in particular. I see so many students doing science fair projects with survey data, and it has some peculiarities to it in some ways, and there's just some common things that I see over and over again, and just want to talk about some strategies for dealing with those things. If you all have a question at any point today, feel free to just drop it in the chat, or even unmute yourself and just pipe in, and I'll take your questions as they come. And then I think we should have plenty of time at the end for some questions as well. So we're going to go over a couple of guidelines for working with survey data. This webinar is kind of loosely based around a blog post that we put out relatively recently, that I can share in the follow-up materials. I can share that post as well. Some of you may have seen it if you are on our email list. But I'm going to loosely kind of go over that as I go through the webinar today. And bear with me, I'm working my mouse furiously here to admit people from the waiting room. Don't want to leave anyone sitting out there. But some of these guidelines that I'm going to be going through today is kind of first step that I think if you're coaching science fair students and they're really working on any kind of scientific research project, but especially surveys, is they need to define their research questions carefully before you even get into any kind of data collection. Some examples of that. And there we go. If you can mute yourself unless you want to ask a question, so we don't get a lot of background noise there. So defining your research questions is really important. And then number two, I think this goes part and parcel with number one, is to name your variables and really define the variables that you have in your experiment, and really think about what variables am I going to need to have information on to answer my question. What are the variables that are in my experiment? This will also help guide which questions you write, because you only need to write questions to collect data for variables that you want to analyze. So naming your variables is important. And number three, I think it's a good idea to plan out what your graphs will look like with and without support for your hypothesis. So if you've developed a strong research question, you're going to, after you collect your data, you're either going to be able to say that, I have support for my hypothesis, or I do not have support for my hypothesis. And it's a good idea to sketch out what those graphs will look like. Now, you can do that in a very sophisticated way, actually create, spreadsheets with dummy data and produce digital graphs. But oftentimes just a sketch will suffice for each of those conditions to plot out what your data will look like with support for your hypothesis, and then without. And then once you've done that, you're able to develop your survey and keep it as short as it needs to be to collect the variables that you're going to need to conduct your analysis. And so just because you can ask more questions doesn't mean you want to. We've all taken a million surveys. I think in general, people prefer to take short surveys. But the other reason for that is you create more complex analyses if you, and more analytical work, data cleaning, if you have a bunch of variables collected that you don't plan to analyze. So think about what you want to analyze and collect that data. And I know there is a trade-off in that you can't go back and get more data later. So there is a temptation to just ask everything you possibly can in a survey. But I would say if you are mentoring students, I would coach them against doing that. I would encourage you to really think hard about what is the data that you want to get for your analysis, and make the survey as short as it can be and still accomplish those goals of obtaining that needed data. And then finally, you want to formulate your questions very carefully. You want to try to do so in a way that is not going to influence the response. If you're doing some kind of Likert scale questions, like 1 to 5s or 1 to 10s, you want to balance the extremes, and so that they're, not have one extreme be a far more extreme than the other. You want them to be kind of balanced. And I think in general, you want to avoid absolutes like never or always. And if you do include absolutes like those, you want to make sure you have sort of multiple gradations, so people aren't forced to choose or to not choose one of those things as well. So these are kind of guidelines for working with data, particularly working with survey data that we see so often in student science fair projects. So I want to go through a couple of examples of what I mean about formulating questions and then defining the variables that will go with that. And these are some example questions that are going to pertain to the data set that I plan on walking through. And this is actually real data from a real science fair student in Palm Beach County, Florida. And I worked with the teacher of this classroom and the student to kind of coach them through what kind of analysis they could do with these. But so first you want to define these questions, narrowing them, making them as specific as they can be, and then as you go through with each question, I just kind of want to go through the process of how you might define the generic variables that you want to collect for each of these, right? So if we take this first question and it's, are there gender differences in attitude towards AI, artificial intelligence? Well, if you think about what am I going to need to conduct an analysis to answer this question, I'm going to need some kind of data on gender. And I would say in most cases, that's probably going to be categorical. And it's going to have things, values such as male or female or other, but whatever range of possible values you want to put in there, they're most likely going to be categories. And then to see if that gender category is associated with attitudes toward AI, you're going to need some variable that measures attitudes toward AI. And it could be some kind of attitude score, which is numeric. Maybe it's the sum of several Likert questions, and you make a new variable that is that score. Maybe it's a single question that you ask them to rate their attitude, and the answer is with a score. Or it could be an attitude response that's categorical. It could be, do you think AI is good or bad? And you could have them, answer good or bad. And that would be an example of categorical. But it's good to think about before you do this, as before you actually go out and conduct your survey, what are the variables that you're going to need to analyze that? And, similarly, if we look at the next research question on there, are there differences in attitude towards AI by education level? Well, we could put, again, education level could be a categorical variable with values like, high school education, college education, graduate school. And then again, it could be attitude score, which would be numeric, or attitude response. And again, I think it's a good idea for students to start thinking about, are they going to collect values of a variable that are going to be in the form of categories, or are they going to be in the form of numbers? Because this when they go through the exercise of thinking about, how do I want to display these data on my poster, in my paper, they'll be able to think about possibilities that work for either numbers or for categories. So I think you get the idea. We're not at this point, we're not writing survey questions yet. You don't want to jump in to writing those questions right away, but you want students to think about, what are those variables there. And since I'm without my typical co-host tonight, I just want to pause for a second and see if anyone has any questions, just to prevent me from doing an hour-long monologue on Zoom here. So any questions or comments that people are thinking about at this point before we get into actually working with some data? Okay, well, if you have any, drop them in the chat. I'm happy to take questions as they come. Let me stop my screen share for just a moment and queue up my next set of visuals here. And the next set of visuals. Okay. So the next set of visuals, I want to actually go, and we're gonna shift from these kind of overarching guidelines and rules, and we're actually just going to get some practice working with some real data and kind of walk through it together. Again, if at any point you have any questions or comments as we're doing this, go for it. But I'm largely going to be modeling here. I'm going to try to narrate everything I'm doing. I'm going to talk about why I'm doing what I'm doing. And we're gonna go through that. One question here, Christina Gremsky says, I've read that some people don't consider Likert scale answers as numeric, but others do. What do you think? I think that is exactly right. And I think there is cause to do it either way at different times. I think you should, with Likert scale questions, you should think really hard about are the different numbers in there, do they really represent a continuum, or do you think that they're functioning a bit more like categories? And this is one of those areas where maddening, it can be a little bit frustrating that there isn't just like a one kind of pat right answer, but you really do have to think about the individual question, the individual scale you're presenting. I know personally, when I see things that are on like a 1 to 10 scale and it's a continuum, I tend to like to see analyses that treat those as numeric, because I think there is a lot of room for difference in there. If it's a really compressed Likert scale and like there's maybe 3 options, 1, 2, 3, in those cases, I tend to feel better about analyses that are treating them as categories. Because I think it's just more of stark differences between them, and you're not maybe able to parse out, the subtle differences between a 1 and a 2 and a 3, but it's more just, is it in this category, is in this category, is this category? So again, that is a tough question. I don't think there's one right answer, but my general feeling is if you have like a 1 to 10, I usually want to see that as treated as a numeric. If it's a compressed scale, I like to see that as categories, but there's arguments for doing it both ways. So that's a good question. 1 to 5, I don't know. Again, with a 1 to 5, right? It's not as extreme as 1 to 10 or 1 to 3, but in there, I would try to look at it and really think about, given the way the question was written, do I think that these answers really represent sort of an even continuum along 1 to 5, or do I think it's kind of jumpy, and are they functioning more like categories? And then you could do that. Another thing you can do to be a thorough scientist, or to coach your students to be thorough scientists, is you could do the analysis both ways. You could first code the variable as a numeric, then you could switch it over as a categorical, and you could run the analysis all the way through to stats, whether you're doing maybe some kind of chi-square if it's categorical, or you're doing some kind of ANOVA or t-test if it's numeric, and ask yourself qualitatively, am I getting the same result doing it both of these ways, right? If the answer to that question is yes, well, then I think your student can report, both of the analysis they did and say, it didn't make a difference which way we did this. And then, they look like they're being very thorough. And I think science fair judges would probably like that as well. It becomes much more interesting and harder to interpret if you get sort of two different results, right? Where one is significant and one is not significant when you do it two different ways. That also should probably, force you to really critically look at the conclusions you can make and think about, well, how much confidence do I have to say this if, by changing the analysis a little bit, the whole thing falls apart. Yeah. Yeah, Chris Olson has a comment there in the chat to everyone, and I agree with that. Those are good guidelines that to think about. Do you have enough categories in a likely scale in there as well? So I think I'm going to move on from that topic, and I'm going to share my screen and actually look at some student survey data. This is almost the exact data that student that I was helping to mentor in Florida had, with just a few tweaks here to illustrate some things I wanted to show. And then the other thing I want to say is I cut this way down. The student, I think, originally asked like maybe 18 or 19 questions, and I'll be honest, I think there were too many in there, and cut these down, but there are way too many just for using it as an example in this case. So just kind of want to run you through the data. The first 3 variables collected are these kind of categoricals that are sort of demographic. What is your gender? What grade are you in? What is your highest degree? On a scale from 1 to 10, how much do you know? Or sorry, so I'll pause for a second. Those first 3, stop myself. Those first 3 are sort of categories about, who was the respondent. And then the rest of them are then getting into their opinions. This first question was a 1 to 10 scale question. Self-reporting, how much do you know about artificial intelligence? And then the remaining questions, the remaining 4, were all categorical responses about what do you believe, or what do you think, and they were all yes, no questions. So do you think AI has the potential to decrease employment in the future? Do you believe AI is powerful enough to manage business in the future? Do you think AI may lead to a dystopian or grim future? And do you support the manufacturing of AI machines? I think, and this student, I think, actually picked this topic before the whole Chat GPT thing blew up too. So I think it's now something that students are perhaps a little bit more interested in going forward. They may have asked different questions, probably something about the role of Chat GPT in education, because that's such a hot topic for teachers and students alike right now. But I'm going to go ahead and I'm going to bring this data into DataClassroom and kind of illustrate how we can use DataClassroom as a tool to do this. So first thing I'm going to do is I'm just going to copy the URL to this Google Sheet, and I'm logged into DataClassroom here, and I'm going to grab the import button that's on the lower left of my dashboard, and from here, I'm going to fetch a spreadsheet from Google Drive. So I just paste in the URL there. You can also do, this is brand new in DataClassroom, but you can browse through your files in Google Drive to pick them that way. But I'm going to fetch and bring it in. And we've now got this data set in. And so it's going to start us down this checklist of data entry in there. And it's giving us a warning that is just so common with students working with survey data. And this is where you saw the data sheet we had, and they left instead of naming those variables, there was an entire question in there. So like, for example, question 8, do you support the manufacturing of AI machines, right? And so we're gonna go ahead and fix this. And this is something I recommend because you want to be able to visually explore your data and try to plug some of these variables into different statistical models. And all of this text as variable names is not very conducive to looking at that output and making graphs. So I want to show you how to easily do this in DataClassroom. If you click this little pencil, so I'll go over to question 1, and you can see it's the name of the variable is now, what is your gender? And I'm going to click this blue swap button, and it drops that question down into the description. And I'm going to rename this variable and call it gender. And now you can see it's just got the name gender. I'm also going to select the type as a category. And you can see now, if I want to know what that original question was, I can hover on the little blue eye and I can see that question. So I'm going to do this really quickly for all of these. So I'm just going to kind of give these variables a name, and we'll call this highest ed level. And we'll go through here. So this is like, we'll call this, self-reported knowledge. And this is a 1 to 10. Maybe I'll even, I can even do a little note about that. That should fit on a label. Okay. And then like this one, we'll think a little bit about, what do we want to call this? And we'll call this like decrease employment, belief. So we'll just give it some name. I misspelled sorry, I'm on the spot here typing. I was the worst in my classroom and writing on the board. My students were just like always aware, just be like, if I misspell something, you have to tell me. And then, so like this one, let's say like manage, we can call it manage business beliefs, something like that. We'll call that.
God bless you.
And we'll swap this, and then we'll call this one grim future belief. And we got one more, and then we'll call this like support for AI machines. Okay, and now we've done that, and we've renamed all of our variables. Some of them could maybe even be a bit shorter, but they all basically fit on a graph. I'm going to go through and choose variable types. And again, if you're new to DataClassroom, you can hover on the little caution triangle, and it'll give you some tips on how those are defined. And I'm going to say 99% of the time you're coding these as numeric or categorical. So this is a category. We're going to call this Likert 1 to 10. We're going to do this as a numeric. And then we're going to do these all as categories. And you saw as we do that, we're checking off things on this data preparation checklist. And if you're looking at this flow chart, we did the data import. We're down to the prepare, and you can see we have a green check mark for each column has a typeset, and then it's still giving us a warning that column 3 is a little bit too long. So we'll change that and we'll enter in a description too. So column number, which one was it saying? This one is a little bit long. Drop the 10 here. And then I'm going to put in a description up here. And this is a best practice. Remember for your students to remember what their data sets are when they do this. You can put in a little bit of information or a lot. And I'm going to say here for this one that has is still a little bit too long, I'm going to ignore it for now. And if it really causes us problems, we'll go back and hit it in the future. And you see, I got a blue check mark here because I ignored it. But I'm ready to go on. And so I'm going to go over to the graph and to explore these data in just a bit here. And
can you mute Joe?
Yeah, I'm trying to see if I was going through and muting people right now, Christine. Thanks for the recommendation. There we go. So what I want to do now, and this is something I believe to be a best practice and a good idea to coach students through, is when you first get your data and you've done all your preparation, you should come into the graphing window and kind of look at how each variable is distributed, whether it's categorical or numeric. Get a sense for what kind of responses you actually have. So I'm going to look at the categoricals first. So like if I look at gender, I can see, okay, I've got, 149 males, 131 females. So basically an even sample here. So we're not going to have to think about, any issues related to that. We can more or less say, hey, we had about the same amounts. With grade, and you can see what I did is I queued it up. I clicked show, and then over on the control panel, if I want to show grade, I just click the X for that, and I can see, looks like we have, mostly high school students here, 117 upperclassmen, 120 lowerclassmen, and then we have 43 in this college category. If I want a reminder of what that is, because this is kind of a long label, I can go up to grade and look at values, and it says I am a college student. I can also change this label and just say college here. And now everywhere where that appears on a graph, it will say college, even though the data table still has all the same values in it. It will change that. Also want to show you, if I want to change the order of display, and like I want to put 9th and 10th grade together, these arrows on the order will change that. So I just bump that down, and maybe this is a more logical order to display those. So let me go and look at highest education level too. This is an interesting question to have in here because it's a little bit redundant with grade, and you may, your student may have considered not taking both of these and just taking one, but you can kind of decide. And this also allows you to see that for master's degree, I only have 4 samples, and for other, I have 15. But like looking at this, if you wanted to do any analysis with highest ed level as an important variable in there, I would consider excluding master's degree because you just have so few samples there. And just to show you, if I wanted to do that again, if I click on values for highest ed level, I can go ahead and exclude master's degree. And now when we go back to the graph, we won't see those responses, and they're hidden unless we de-exclude them. So that's also, something you're kind of looking at. Self-reported knowledge, this one's numeric. So when we look at this, we see we get a different kind of graph. We get a histogram rather than a frequency plot, and we can kind of see the distribution. We have a lot of responses that have self-reported knowledge somewhere in the middle of the scale, and then a few that are on the higher ends of the scale. It also looks like or no, that's it. Yeah, it was 1 to 10. That's what we have there. When you look at these other questions about, the beliefs, decreased employment belief, looks like we had a lot of yeses and only a few nos. Manage business belief, we had somewhat more even responses, but a lot more yeses. Grim future belief, really split. That's an interesting one. And support for AI machines, a lot more yeses than nos, but a little bit of a split. So looking through that, this is an exercise I recommend your students do, looking for things like weird outliers, looking for things like categories that were hardly represented at all, to the point where you can't use them in analysis, and looking at these things. But now when they're to this point, I think it's time where you would want to start thinking about what those research questions were, and thinking about what were the variables that I needed to answer those, and then think about choosing a graph that will get those variables on the same graph so that we can answer those questions. I'm just going to really quickly peek back at some of the research questions that were there. So we could say, are there gender differences in attitude towards AI? So we need that variable of gender, and then we need some variable that measures attitude toward AI. And so let's go, and I'm going to put gender on X, and things that could be, measuring an attitude toward AI. Well, first, toward attitude. So it's some of these belief questions. So we could look at things like the decreased employment belief, and these, right here, I don't see any kind of dramatic gender difference between these right off the bat. We could look at something like this managed business belief. One other thing, when you don't have samples that are 100% even, I think we had more males in the sample than females. What we might want to do to look at these by appearance a little bit more clearly is we might want to make these into stacked frequency plots or stacked bar charts. So if I go into the appearance menu, you can see the first option that I have when I'm looking at this kind of graph is to stack it. And then I'm going to choose to stack it as a proportion. And this is really helpful with survey data a lot of times, because when you have uneven number of respondents in your two categories like gender, this changes the y-axis into percentage. And so we can do more of an apples to apples comparison, certainly visually. And then, statistically, it's going to use the actual numbers that we had. But this helps us to see if a difference is real, or if it's sort of just kind of looking like a difference due to different numbers of male and female respondents. So we can look through these. Don't seem huge difference. This one looks a little bit interesting, where it looks like 87.7% of males had support for AI machines as yes, while only 73.1% of females did. And so, if you're working with really, with younger kids, that might be as far as they go. And they might, in their reporting, they might say, well, there was, more males supported AI machines being built than females did. We could say it was greater than 10% difference between the groups. And maybe that's where you stop in your conclusion. But perhaps you're competing at a higher level with science fair, and you want to introduce some statistics here. The graph-driven hypothesis button over here, the time to go for this is after you've made a graph and after you've thought about what the conclusion is telling you, and your sort of, your visual assessment. If I go in and click that, it will recommend the chi-square test of independence, because we are looking at two categorical variables and seeing if one affects the other, or are they independent of one another, or are they dependent on one another? And when you go to calculate that, it'll give students this pop-up, why are we using the chi-square test of independence? Well, it explains that these are the variables we have on there. It will give a little explanation of when we should use it. When you have two categorical variables and you want to know if the value of one appears to be dependent on the other. This, by the way, if you are competing in science fair, this is exactly the kind of response I think you would want a student to be able to share with a judge when a judge says, oh, you did this statistical analysis, why did you do this chi-square test of independence? This is sort of the lay explanation here. If we go to actually run that, it shows us, we have a highly significant difference here, less than 0.01, meaning that this is greater deviation from sort of an equal distribution across both genders. This is a deviation from what we would expect, due to random chance. And this is less than a 1% chance of getting a difference this large between the genders, if in fact there was no real difference in the population. And so this is the kind of analysis they could do. And thank you for your comment, Carlos. We could, and this does bring up a good point, and we're making a university level version of the DataClassroom platform, but a lot of things between the two platforms are the same, and that focus on interpretation is the same, because if it's good pedagogy for a 12th grader, it's also probably good pedagogy for a first-year college student. And I don't think you need to change things dramatically for learners, because learners are learners, at whatever level they're at. Christina, you had a question there. Is there a way to reduce the width of these columns? There isn't an explicit way to reduce the width of the columns. There are some kind of sort of tricks you can do to change the dimensions of the graph and the columns a little bit before you export it. So say you wanted to use this in a presentation, and maybe you didn't want as square of a look. Maybe you wanted more rectangular dimensions for the graph. There's a couple of things you could do. One thing you could do is this up here on the white bar. I could hide that row of variables at the top, and that will change the dimensions a little bit there. The other thing that I could do is I can compress the screen size a little bit, and you'll see how my graph changes. If I go too small, it'll tell me your screen's too small. But if I did want this to be more of a rectangle, now when I copy this graph, it'll look like this, and I can take it and I can drop it and paste it wherever I want. So while you don't have total flexibility to change the width of the bars, you can play with the dimensions a little bit by changing the size of the screen window. We may have some more command of the graph dimensions coming in the near future, but those are still in development right now. Good question though. Okay. So from here, I also want to look at, so we've been looking at these analysis of this kind of categorical versus categorical questions. I want to look at, how the graphs would be different if we're looking at like a numeric variable, like say self-reported knowledge, and maybe let's look for maybe a highest ed level difference here, and we'll do highest ed level and self-reported knowledge. And we see we can't shoehorn this in to a bar graph or a stacked bar graph. But what I can do is if I put self-reported knowledge on X, we can see it as a histogram. And right now we're looking at it split up into categories, whether a respondent had support for AI machines, yes or no. But we could also look at that as a sex difference, so we can or gender difference. We can look at, we could add descriptive statistics above here and look at, where the means and standard deviations are, or maybe We want to look at means and 95% confidence intervals. We can see that they're kind of close to one another. I'll also say when you don't have even numbers of your two categories, and we already looked that we didn't have males and females that were exactly even. I'm not as big of a fan as the histogram. In these cases, I much more prefer a dot plot. And here I also want to make out or kind of make the point that with Likert scale data, where all the data are at discrete intervals, sometimes just looking at the dots without some kind of descriptive stat is tricky to see. Let's see if we look at, this is a nice way to look at it. Because I think it really emphasizes that there is, very little difference between the genders here. Their self-reported knowledge score for females 5.08, for males 4.9. So these are very, very close to each other. The interquartiles are overlapping, almost perfectly there. And then also want to make the point is like, this is a great way to look at your data initially. And for continuous numeric data, I really do like keeping the display of the raw data and doing some display that shows the dots. But sometimes with this Likert data, it's visually you can't see the distribution as well, and sometimes you might want to choose to hide the dots and just look at your box plots or something like that. Or even something else I like to do, just a kind of a visual presentation tip. If I do want to show that data, I'll de-emphasize it by like cranking down the edge width on those points, and also reducing the size of the points so they kind of go into the background a little bit more. And then oftentimes with this, I'll choose to position my box plot dead center on top of the data, and then I'll go with some version of this kind of display here. And this we should run the stats on this too, but I'm interpreting that as no difference between the groups. And if we run the t-test between these two groups, we get a p-value of 0.48, well above the sort of scientific 0.05 threshold, but little to no indication the groups might be different here. They're virtually identical in terms of this self-reported knowledge scale. All right. Well, with that, I'm gonna jump back to this for a second, and I just wanted to share my contact information. I'm not going anywhere. I would love to stick around for any questions that you have, and maybe we can have a little discussion. But if you need to drop off and you have any follow-up questions, feel free to drop me a line. I'm Aaron at DataClassroom.com. I love hearing about science fair projects that people are engaged in. So I wish you the best of luck with this science fair season. If you do have to drop off, and then I guess right now I'll ask: Does anyone have any questions they'd like to talk about? And I'm happy to talk about anything within Data Classroom, anything about experimental design or surveys in general. Do you have any questions for me?
The refreshers are always helpful, so thank you for doing this again. I always learn something new.
You're welcome. You're welcome, Christine. Where are your students at with science fair right now? Have they presented?
Yeah, I'm on sabbatical, so
right.
yeah.
Okay.
I'm hoping they're on course.
Right. And congrats on your Teacher of the Year sabbatical.
And good night. Bye.
Bye. Somewhere, Man Whitney U, can that be done in Data Classroom? I want to show you some range of statistical tests. If you are running on a teacher account, you will be able to do this, to see these. and Christina, I think you're actually, if I remember correctly, you're mentoring a student who has a Data Classroom U account. So if you're a teacher and you want to switch between these, you go to profile, and in your profile, if you change your level from middle high school to college, you will change to the DCU package, the Data Classroom U package. Students will not be able to switch back and forth between these unless they already have a college package. But if we go back to a data set, and I'm just going to open up, can open up this one. Actually, we didn't save that. Let me open up the version of it I was playing with in preparation for this. So this will likely, this one's not formatted either, but I can really quickly like do one or two of these. If we go over to the graph and say we wanted to look at these, question 4 is numeric, so we'll put that there and we'll split this out. But if we go into the graph driven test, you'll see we have Mann-Whitney U in there, and as well as Kruskal-Wallis, as well as ANCOVA. So there's a few additional tests in there in the DCU package, and Mann-Whitney U is one of them. If you want to do a Mann-Whitney U instead of a t-test, you check this box to select non-parametric tests, and it will go ahead and run the Mann-Whitney U, which instead of focusing on numeric values, I believe it turns those into ranks, and we'll look at data that way. So you can switch between t-test and Mann-Whitney U with that checkbox. Yes, Amani has a question in the chat. Will you get a recorded copy of the webinar? Yeah, you will. We post it on our website, and we'll send you all a link to the recording. We try to get them out in a week. I can't guarantee it'll be exactly within 7 days, but usually within a week and a half, we have that follow-up email come out. Okay, well, if there are no more questions, with that, I will say, thanks for joining me, and have a good night. I always appreciate talking